These are the tectonic plates. So this is the North American plate, this is the Pacific plate, and the Australian plate, for example. Where the plates join together or in contact with each other, we call those the plate boundaries. We've got different types of plate boundaries that are dictated by the directions in which the tectonic plates are moving relative to each other. For example, these two plates here are moving towards each other, these two are moving past each other, and these plates are moving away from each other. We have three different types of plate boundaries, and they're determined by what's happening with the movement of the plates. The first type of plate boundary is where we have two plates that are moving together. So if we've got two convection currents here moving in opposite directions, it's pushing the two plates together. This is called a converging boundary. Converging, so they're coming together, they're converging. So we've got a couple of things that can happen here. If one of these is an oceanic plate and one of them is a continental plate, continental plates are thicker. So the continental plate's moving this way, the oceanic plate is moving this way. What's going to happen is the oceanic plate is actually going to drop down underneath the continental plate. So we're actually losing this material here. It's actually being, it's going to melt and become magma. So for that reason, we also call a converging plate boundary a destructive boundary, because we're destroying the crust of the Earth. So this is what happens where we have an oceanic plate and a continental plate. So where we see this, we often see a mountain range like the Andes mountain range. We often see volcanoes here because pushing the magma down often forces a volcano to come up as well. And of course we could see earthquakes as well, because what happens is that these plate boundaries, it doesn't just move gently like this. What happens is it sticks, and then slip. So more on that another time, but that's a converging boundary. So the next one we have is where we have plates that are actually separating. So this happens in a situation like this, where we've got two convection currents that are moving in opposite directions. What it actually does is it splits or separates the two plates. And what actually happens in between is that the magma actually comes up through here and forms new crust. So we end up with what we call, like a ridge here, like the mid-Atlantic ridge that we see inside the ocean, where we've got this big ridge, mountain range under the ocean, where new crust material is actually formed because the plates are moved apart. The third, so this is called a diverging plate boundary, and because it's actually making new material, sometimes we call it a constructive plate boundary. The third type of boundary we have, I'm going to try and draw that slightly differently, is, so imagine a 3D this time. So this is what happens when we have two boundaries that actually, or two plates that actually move side to side. So one goes that way and one goes that way. Now, so we're not actually creating or destroying the surface or the crust, we're actually transforming it. So this is called a transform boundary. So why does it transform? Well, it actually creases, and this is the sort of thing you see in like the San Andreas fault line in the USA. That's a transform boundary. And it's sometimes called a conservative boundary because we don't actually lose or gain any and we don't lose or gain any crust. So there's our three different types of boundaries. Now, which ones have earthquakes? The converging boundary does. So this is where we have an oceanic plate and a continental plate. So for example, Japan, New Zealand. So a diverging boundary here, this happens under the ocean. It also happens in Iceland, interestingly. That's why, so Iceland is actually separating, and that's why they have volcanoes in Iceland. And the third one is a transform boundary. So you definitely see earthquakes here. Again, it's that stick, 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 and slip. And this is a classic one in the San Andreas Fault in the USA.